here. We are, both of us, and it's so heartwarming to see that the crowd is coming just to know about AI and relevant topics. So a little bit about us. I am Sara. I'm the CEO and co-founder at DivERS. I'm also working mainly on business development part. I'm working as assistant professor at the TU Mechanical and Civil Engineering. And my main research topic is regarding production digitalization and plant simulation and automation perspective of product and production design. I have around 10 years of experience working on digitalization and automation. And Alireza, he is our CTO and co-founder also. He is working mainly on the product development and in particular the AI-related topics at DivERS. He's also the senior data scientist at Bruel and Care Vibro, where he's leading the topics mainly relevant to machine learning for vibration condition monitoring. He also have around 12 years of experience working with AI-relevant topics. We founded DivERS around 1.5 years ago, and we already have attract attentions from potential customers. We have a couple of round of testing at the TU for recruitment process. We also won the Best Digital Startup Award from Venture Cup Denmark, and we also attract 2 rounds of funding from DTU Skylab and from Innovation Fund Denmark InnoBooster program. And the aim is to remove biases from recruitment process. That's the main goal of DivERS. And today we are here just to focus on the AI part of DivERS. But of course, I have to give you a kind of general information about what is DivERS, because we are going to talk a lot about algorithms. Alireza will give that presentation, but I think it's very necessary to give the fundamentals of what is DivERS, how it works, and why do we need DivERS AI solutions, and on which level we are using AI in our system. So the problem is that we are all biased. And discriminations during recruitment and in workplace is due to both our conscious and unconscious and conscious biases. It leads to a homogeneous workplace, and unfortunately, it reduces both innovation and return on investment. Based on San Francisco Federal Bank, this lack of diversity leads to 19 trillion Danish kroner loss per year, of course, in a worldwide dimension. And maybe that's why that you're hearing a lot about diversity, inclusion. All the companies are trying to react on it, and they're all looking for a solution. So we are maybe in the right time, in the right market. But what we are looking at in DivERS is shortlisting process. Let's look at the recruitment process and see what is happening when we are recruiting or the companies are recruiting. First of all, they have a need for a resource at the company. So they define the criteria and the requirement for that resource, and they prepare a job advertisement, or what we call job descriptions or job advertisement, and they will advertise it. In the next stage, the applicants will apply. And this is the phase that the companies start to shortlist the applicants based on their qualifications, hopefully, based on the qualifications. And then we have the interview and the employment section afterward. But due to the limited time and high number of applicants, this shortlisting phase is the most important phase to face biases and remove them. And that's what we are trying to do. On the other side, shortlisting, automatic and anonymized shortlisting is very important, not because of this speeding up the recruitment process, but also because we want to increase diversity. And this also have a significant influence on the next stage, which is interview, and the biases we have in the interview phase. But how DivERS works, if I want to summarize it and simply tell how we are working in DivERS, first of all, recruiters upload the job descriptions. And that's all we need from recruiters. We need a clear, transparent job descriptions, not only for the applicants, but also for our system. And the reason is that we need to know exactly what is the job criteria they have in mind. The reason is that in the next stage, DivERS machine learning algorithms will generate unique questions exactly based on these job descriptions. These questions are unbiased, they are objective, and they are job-tailored questions. And we are asking very precise, objective questions from applicants, and they will answer these questions when they are applying. And finally, DivERS will generate a shortlisted, anonymized shortlisted list of applicants only based on the qualifications. So DivERS is a data-driven technology to remove biases. We help the companies to remove biases and realize a modern workplace with higher performance, innovation, and engagement from their employees. But we don't only contribute in the cooperation level, but we also try to contribute in the social level to achieve SDG goals number 5, 8, and 10, which are more relevant to diversity, inclusion, and equality in the workplace and in the society. So I will hand over to Alireza for more detailed information about AI part.
Thank you so much. So I'm Alireza. As Sara mentioned, I'm the CTO and co-founder of DivERS. And if I want to say a little bit about my background, I also have the background in physics. I got my PhD here at DTU Physics a couple of years ago. Worked in the university for a couple of years as a researcher, and then moved out into healthcare sector for a couple of years. And in the last year or so, I'm also working as a senior data scientist in Burul Vibro, working on the vibration condition monitoring. So I try to use AI and machine learning basically in different fields from different perspectives. And what I'm going to talk about today is going to be basically the use of machine learning in DivERS. And to be honest, because I was not sure about the background and experiences of the audience, I thought I'm going to try to have a very brief introduction to the field in general, try to also explain some of the terminology. And I hope that it cannot be boring for some of you. Some of you probably are even more expert than me in the field. So please bear with me. I also going to talk a little bit about the technical details, hopefully at the end. And so this is a schematic of how typically we solve a problem. And this has been the way that we are doing this probably in the last couple of centuries, that we start by study a problem, then using the laws of physics or math or other laws. And then based on that understanding, we're writing some rules. Then we are going to test the rules to see how the output is generated, whether the error is in the acceptable range. If it's acceptable, of course, we're going to continue. If not, we are going to do iteratively, try to understand the problem more, write more complex rules, more complex. And at some point, these rules, they can be very complex. When we want to replace machine learning, what we are going to do is that we are going to replace the writing rules part by a machine learning model, which is going to be trained by data, and indeed by a huge amount of data typically. And of course, the question is that why we do this. The main reason, there can be different reasons, but at least one of the most important reason is that it can be very complicated. Those rules that we human, we cannot keep track of them. And so that's why we ask a machine learning model to look into the data, observe the data, and finally learn those rules, basically. The title of the talk is AI. And I thought I need also to explain a little bit about what is AI, what is machine learning, because sometimes a lot of the words, they are going around, and of course, it's not very clear what we are talking about. And that's why I thought this picture can be useful. So I'm going to start with the artificial intelligence, AI. And basically, any techniques that enables machines to do something that the human can be called AI. In that sense, we could say that AI has been there for many years, probably a century or so, even more. And a subset of AI, which is recently people pay attention to much more, is the machine learning, which basically it means a set of algorithms that can learn from the examples or data without explicitly being programmed or without writing some rules. And in the last 10, 15 years, there is another subset of these machine learning algorithms, which are called artificial neural network, ANN, which are a set of algorithms that are inspired by human brain or other biological units. They have been very attractive because, of course, there have been some breakthrough, and also the computational power has increased exponentially in the last decades. So that's why they become interesting. And the final part, which basically is the one that recently we hear a lot, is about the deep learning. Probably everyone here has heard about the the ChatGPT, new Bing search engine, and a lot of other applications that they are start to use the deep learning. And this is the part that basically fascinates us. It start to make some stuff that it was almost impossible a few years ago. So, and I think what we are going to talk at the end of the talk is going to be a little bit of deep learning. Machine learning are everywhere. And this is actually, if we just wake up from the morning, the first thing that probably we do, we just take a look at the phone and then check our email. And starting from that moment, we could see that the emails are categorized. Probably some of them are filtered as a spam. So this is an example of machine learning. Then we start to write an email or probably reply to a text, and we are going to use auto-completion, auto-correction. We are going to use smart replies, and again, these are another example or other examples of the AI. We may start to drive to the workplace, and we are going to check the traffic, and it is basically a route that I get every day in the morning to check how fast I can arrive to my workplace. And if you're using Uber, then you can get an estimation what is the price. So all of these examples are some tangible cases of using machine learning in a daily life that sometimes we don't even know, or we don't even notice that we are using machine learning that much. In particular, I would like to talk about the machine learning applications in human resource HR, basically. And again, the list is going to be a very long list. I have put some of them here, which is talent acquisition, candidate selection. I can provide some examples for each of them. For example, LinkedIn, probably most of you are using LinkedIn. When the LinkedIn suggests to you a job based on your CV or your past experiences, this is basically an example of machine learning in LinkedIn that try to be used for talent acquisition. Or some big corporates nowadays, they are using these chatbots that try to help the employees to be onboarded. You have a new employee, a lot of questions, you can go and ask the chatbot of that corporate about your problems. And in particular, there's this so-called candidate selection problem that basically a machine learning is trying to find the best candidate for you based on the job description. And that's actually the part that the DivERS is trying to contribute here. So conventionally, the way that machine learning has been used for this candidate selection was that, of course, we have these great natural language processing model, NLP models. You have heard about the ChatGPT or GPT in general as a model. You can try to use these sort of models, try to find, understand the job description, match it with the applicant CV that you have access to. And that's more or less has been done in the last couple of years. And of the main benefits is that it's very fast, it's easy to use, and there is no human intervention, basically. So you have the access to applicant CV, and then you also have the job description. So you try to match them and find the best fit. However, there are a couple of main challenges in solving this problem. And these are also backed by some researches. For example, it has been shown that the CV format can affect the applicant ranking, which is, of course, an undesirable effect that we don't want. Or it has been shown that sometimes the machine learning model can be prone to the human biases. So basically, the machine learning model, depending on the data set that has been used to train, it can be a biased machine learning model. And then, for example, prefer men over women due to the data set that has been used to train that. And of course, these two problems, probably we could solve them. Of course, researchers at DTU and other places, they are working hard to solve these kind of problems. And hopefully in near future, we may be able to remove them. However, there is a third kind of problem that I would say it takes some time and probably a long time until we could reach to that level. And that's the problem that I call black box dilemma. So basically, the recruiters at the end, when they are using these systems, they have no control about how these matching is done. Basically, it's a black box for them. They don't understand it. And as far as we know now, we are hesitant to use it because, yeah, we human, we want to be in control. We want to understand what's going on. And this is not only for this problem, probably it's a big problem for many other machine learning applications, that because we cannot understand exactly what's going on, probably we are a little bit hesitant to use them. And that's why basically we thought that we could probably use AI in a different kind of perspective here. So I guess you have seen this slide at the beginning. So this is how DivERS works. So we upload the job description. We need the job description. But now instead of let the machine learning model choose the candidate, we are going to let the machine learning model to generate some questions, good questions that you may ask from the applicant yourself as a human. So what we want to achieve is that a machine learning can ask some questions from the applicants that are objective and accurate, and based on those answers the applicants provide, then we could try to rank the best candidates. And in that sense, the advantage is that it's transparent, basically, the process. Now, the recruiters can easily understand why this candidate is chosen because of these answers to these questions. And also he or she has the power to control those kind of processes. At the same time, we could remove the biases, for example, because the questions, they are generated by the machine learning model. It's efficient, it's unbiased. And so we try to remove those challenges, basically. This is one example of a job description that indeed it was a position at DTU for a PhD position advertised some time ago. And then we try to use DivERS basically for finding the candidates. And so you could see, I just take one part. It's a bigger or a larger description, but it explains about the job and some of the qualifications that we are looking for. And on the right hand side, you can see, probably I should do it like this, I don't know, but now you can see some question samples that are generated by the DivERS machine learning algorithm. But then the question, of course, is that how we do these kind of things. And as Sara mentioned, we are a small company. We don't have a lot of resources. And so how we can do these kind of machine learning model. And to understand that, we need to understand another concept, which is called transfer learning concept. Let's assume that we have two problems that we want to solve. Each problem has its own data set. As an example, we want to identify a cat on picture. Another example can be identify a dog in a picture. And conventionally, or in the classical way, we are going to train a machine learning model on one, and then we do the same thing on the other one, even though there are similarities here. However, this is not very efficient because we can use a concept which is the transfer learning. So basically, we could train on one of them, learn something, and then transfer the knowledge to another machine learning model, and then be much more efficient. And indeed, this is the way that nowadays everyone using the machine learning in a lot of the fields. So deep learning led us to use that concept of the transfer learning. Nowadays, the large companies like Google, Facebook, they train these very, very big models with billions of parameters, and then they make it available to public. They have their own reason to do that. But what's going to happen is that a small company like us or any other researcher, we could take those models and then retrain them for a specific need that we have. And we could achieve almost the same accuracy as what the Google has achieved in his problem. So this is just a pipeline, and I guess it's a crude schematic of the pipeline, how we are doing this at DivERS. But what we are trying to use, we are trying to use some of these available NLP models. For example, we are using T5 model, BERT, probably one of the most famous NLP models based on the transformers. And what we try to do is that by using this pipeline, we try, starting from the job description, we try to get some questions and desirable answer by the candidates. And what we are doing, if we know what is the desired answer, and then we can compare basically the applicant answer to that desired answer and see how they match. Actually, that's the second part, how we choose the best candidate. But then it's much more clear because we have the connection through the questions. There are a lot of challenges when we want to talk about these NLP, and I'm not going to go through all of them, but just to mention, for example, one of the challenges that we face is that sometimes the job description is not very accurate, and then the machine learning model try to obtain some questions on a job description that is not very accurate. Of course, that will be a challenge for the machine learning, and how we could solve it, we are working on that. Or there are sometimes we have some in job description, they have subjective matters inside them. Then of course the machine learning model try to ask some subjective questions, which is not our goal. We want to have objective questions. So we are trying to remove them, basically, these undesirable questions from the output. Now we should come to the final, I would say, slide, which is more about the what we call ML dilemma, pilot or co-pilot, and the reason is that I think what we try to do at DivERS is try to look from a different perspective. Basically, machine learning has been used more or less as the pilot for solving this problem for many years, or at least for the last 5-10 years. But people were hesitant to use that because they feel that they don't have the control, they don't understand what's going on. And so in that sense, what we try to do at DivERS is that to change the perspective, still bring the pilot, which are the recruiters, to solve the problem, but still let them to be in power when they do. And probably this is just one example, and I believe that there are many other examples that we need to look differently if we want to bring the power of the machine learning out. And of course, we are on the beginning of the road to use the machine learning. I guess we need to learn a lot how to work with them and how to understand them better. And hopefully we can reach to a level that at some point we can also let the machine learning being the pilot for this problem. I guess that's, please let us know if you have any question, or feel free to contact us if you want to know more details about how DivERS works. Thank you so much.
We do have questions in the room. Here you go.
I just wanted to confirm that in the question set, you are using free text answers as well. It's not just multiple choice.
Actually, we have different types of questions, at least what we try to do. So if I show it here, actually, there is this stage, it's a question type detection. So basically, we try to train something, some machine learning model that at least guess what is the best type of question that I can ask from this, for example, sentence. And we are now covering the questions that have answer as a number, for example, or it can be single or multiple choice questions.
But so the answer to that was no, is it? You're not using free text questions in the...
No.
Okay.
No.
Hi, thanks a lot. It was really, really interesting. So I come not from the technical side, but we have a background in humanities and social sciences, and probably I would raise another kind of questions than you might do. I'm really curious as to what extent you have been cooperating and given knowledge and sharing knowledge from people who have like insights into psychology, human behavior, social patterns, and not least, of course, in this case, gender patterns, because it seems to me that there is a huge risk here that you're creating a system that will reproduce bias, but will actually sell the solution as if now we overcame bias and this is then neutral. And some of it, I think, has to do with the fact that it seems to me that you're focusing on questions, but I didn't hear you say a lot about how you evaluate answers.
Yes.
And one of the things we know is that people of different gender often answer very differently to questions where they're supposed to evaluate,
Exactly.
for instance, their own competences. So I'm really curious about what are your thoughts on this and how are you working with this?
Of course. I think in this presentation, we basically try to focus on more kind of technical aspects of these. And of course, we are fully aware of what you are saying. Actually, we already have seen these when we tested DivERS on different positions. And so definitely we are aware of this. And at least the solution that we thought that it can help us to circumvent this issue is that to make the questions as precise as possible, that there's no second interpretation of the question. Because I would say what you're saying is also reflecting in the applicant CV. Men's tend to exaggerate a little bit about, including me, exaggerate about my capability compared to women. And there are researchers actually prove this. So we already are aware actually, and I should also mention we have a third co-founder also here, not in the audience now, but she got a PhD actually in human resource. So we are also trying to also think about the other aspect, which is definitely very important, and try to solve those issues. So I would say this is also the same question in the CV, right? If we do try to look at the CV, there's a good chance that the men do the same. And our solution, I believe, if we could have accurate questions, then probably we could at least remove some of these biases. Let's say about the experiences. If I ask an experience, how many years of experience do you have? And then we make it very concrete, for example, on this topic, for example, probably a man and woman can answer the same question. But again, yeah.
One will count the 2 years they worked in the local supermarket as I have financial experience, and the other one might not. And I think the difference is, of course, that if you're there as a human evaluator of CVs and applications, if you're experienced, you might take that difference into consideration. So I'm thinking, would you need to have a system that would actually sort of balance for that sort of bias? That could be interesting.
Of course.
Do we have another question? Yes, we do. This is going to be the last one before 1 o'clock. You're in luck.
I'm going to ask what happens after an applicant is hired, because there's the trend of psychological safety, and there's a lot of research about, as you saw, self-efficacy, or believing that you can do something well, even though you cannot. But a lot of the troubles with diversity and the value of diversity, I'm coming from the startup world and focus on diversity on startups, where it's okay to disagree, but a lot of the problems resolving from diversity is actually that you don't have psychological safety in the team that you get into. And when you don't have psychological safety, diversity actually tends to bring down efficiency. So that you also need to tackle the problem of psychological safety. Are you tackling that? Because I guess that could be a machine learning or AI case too, and a questionnaire case too. So instead of focusing on the filtering from who gets in, maybe focusing more on the team as a whole and the dynamics there, because if you filter somebody and productivity fails, you kind of like embrace and enhance biases. You understand? So you need to tackle the problem in teams that are not diverse, because it might be because of low psychological safety.
Sure. I mean, I would say, first of all, I think what we are working in DivERS, we are targeting the large corporates, because I would say what the large corporates are experiences in terms of the diversity and the challenges of diversity is a little bit different, as you mentioned, with the small startup and SME. So the solution probably is more suited for the corporates. There's another reason. The corporates, they also receive huge amount of applicants that they need to screen, basically, compared to a startup that probably do not get that much. And I agree with you that even the needs of a large corporate probably is going to be also different from the SME or a small startup.
I think the point I'm making is that that you could ask not only applicants but also the team and the hires because the problem with low psychological safety is that it pulls down people's self-efficacy, and it's like an ever-going loop. So if you heighten people's self-efficacy, you also heighten the tendency to high psychological safety. So there is a whole process, and if you look at the whole things about what's happening about another trend, which is high-performing teams, there's a forming process every time a new member comes in. So you have to have a chance to iterate and start over. And if I just tackle from the problem that you can actually tackle into that trend, because now you're in a very crowded market, I guess. But if you can tackle it more holistically, there might be a chance. I don't know if people would buy it, but I know there's a lot of focus on it right now.
Interesting, definitely. I mean, of course, we haven't touched on that aspect that you're talking, but definitely I think it's interesting as you explained it. So to be honest, I don't have any answer, and we don't have any plan to go on that direction yet.
Could you do it? Could you just ask questions to them?
In practice, yeah, we can ask to any. I mean, basically, the whole idea is that we want to ask concrete questions, objective questions from a text. That's as simple as that, right? Of course, it's customized for the job description. Later, we can customize it for something else.
So I'm going to cut in here, just in the interest of time, people who might have meetings after this, but feel free to network, because it's a great conversation to have.